This is Unit 3, Section 3.3, Inverse Trig Ratios. So as we move from practicing with sine, cosine, and tangent to find missing side lengths, what's more powerful about trig ratios is that not only does it allow us to find side lengths, it also allows us to find angles. And so that's what's more powerful than Pythagorean theorem. If I had Pythagorean theorem and I said, okay, here's 3, here's 4, we can find a side length by doing Pythagorean theorem. However, what would we want to do if we wanted to find this angle measurement? So what if we didn't know the angles on either one of these? Well, we can't use Pythagorean theorem because it doesn't help us find angles. It's only length, length, length. Where in trig, we can use it to help us find those measurements because trig, sine of some angle, relates the sides. So if there are 3 unknowns here, and say we know 2 of them, we can use it to find the third. And so as we're looking today, we've done trig to find side lengths. Today's going to be the more I guess more to me like mind-blowing, like this is what it's so powerful and why we study it not only in this year, but in Algebra 2, Pre-Calc, Calc, and on. So here are the steps that we're going to use to find the missing angle. If you know the sine, cosine, or tangent of an angle, you can use an inverse ratio, and that's what we have this -1 here. So if you look at our calculator, do you see we have sine that we've been using, and then above it, that -1 means sine inverse, cosine, cosine inverse, tangent, tangent inverse. And so in order to find the measure of that angle, you must know at least 2 sides here. So as long as we know 2 sides, not only can we use Pythagorean theorem or trig to find the missing side, but now if we know 2 sides, we can find a missing angle. So if we know the angle and are finding a side, we're going to use sine, cosine, and tangent like we've been using the previous lessons. If you know 2 sides and are finding an angle, this is where we're going to use sine inverse, cosine inverse, and tangent inverse. And so that -1 is read as inverse. So it's not sine to a power, it's just the inverse of sine and the inverse of cosine. So let me show you what I'm looking at. In this example, we know 2 sides, but when we circle, we don't know the angle. So I still circle, even though that's unknown, and I still label like I did before, opposite and across from 90, hypotenuse. But when I set it up, because I circled an angle, immediately I can go to the inverse function. My angle equals opposite over hypotenuse. So we pick SOHCAHTOA. And which trig inverse do we want now for opposite and hypotenuse? We're going to use sine inverse because it's an angle. And then we put in 15 opposite over hypotenuse 24. Okay, it comes from this idea that we could set it up this way. Sine of x equals 15 over 24. But again, x is inside of sine. So what we're really doing is we're going to say, okay, let's take the inverse sine of this, which cancels out sine. And if I do it to one side, I do it to the other. And that's where we get to what we got right here. I just skip this part of doing sine inverse on both sides and go straight to I'm looking for an angle. That means I have to use inverse. So my calculator, I can put this right in since x is by itself, which is nice about finding angles. So I'm going to use second now to get to the green letters above sine. And now I have sine inverse, and I can put my fraction of 15 over 24. Let me delete that. Gotta put it over 24. And then when I hit enter, it finds my angle measurement. So that angle measurement, rounded to the nearest tenth, is 38.7 degrees. And so now, as we're finding angles, we want to make sure that we're labeling it as degrees as well, because this is not a missing side length with unknown units. We know the units of our angle is degrees. On number 2, we'll do the same thing. We circle, that's our unknown. Immediately I know I'm doing x equals and picking an inverse based on the sides I label. Here's my hypotenuse across from 90 and close to adjacent here. So hypotenuse and adjacent, that's going to be our cosine inverse for an angle, and it's adjacent over hypotenuse. So on my calculator, now I can use cosine inverse, second cosine, use my fraction button to do 8 over 11, 43.3. And that's in degrees. So again, as we're using this trigonomic ratio to find it, an inverse operation allows us to find angles. The sine, cosine, tangent allows us to find sides. So that's why we do inverse to find angles. Number 3, circle. As soon as it's x circled, I know I'm picking an inverse based on my opposite and adjacent, which will be tangent. So now I'm going to use tangent inverse to find my missing angle. Opposite over adjacent. Go to my calculator, second tangent, and do my 20 divided by, get out of here, out of 37. And that angle will measure 28.4 degrees. And on to the next one. Circle, that's an angle, x equals. Label my sides, I have adjacent and hypotenuse. So ka, ah, so that's going to be our inverse cosine. And I'm going to take adjacent over hypotenuse. So x equals, to my calculator. Again, you have to have a calculator to do these. I can't do these in my head. I don't know these ratios. But our calculator is programmed for it. So if we want to do the fraction, we can, or we can write it out as the 18 divided by 23. And we would get the same thing, 38.5. And that's in degrees. 2 more, practicing our inverse. So we circle and label. We have opposite and hypotenuse, which is sine. And again, there's no solving when we're doing an angle. We just have to know which inverse we're going to pick. So make sure you're labeling this correctly, that this is sine inverse, not sine, for opposite over adjacent. So that we get x equals, and we can find that measurement. So now I'm going to do second sine of 40 over, 41. And I get 77.3 as that angle measurement. Degrees. Last one here, we have x, okay, we have opposite of x, we have adjacent to x, which is our tangent. X equals tangent inverse, because we're looking for an angle, opposite over adjacent. To our calculator, we want the inverse tangent, 7 over 5. 54.5 degrees. So when we're finding a side, we might have to cross multiply, maybe divide if we have to get our variable by itself. For an angle, once we have it set up, we should be able to find it very quickly. So on the next part, this is where we're kind of reviewing and putting those two things together. So if we want to use trigonometry, we can use it to find a missing side or angle. And the steps are going to be the same. Circle and label, pick a trig function, and solve. Circle and label, SOHCAHTOA and solve. So when we think about what we're circling, okay, we're always circling the angle, but if it's missing, we go to inverse trig. We always label our sides, but our trig function could be trig or inverse, depending on what we're looking for. So it depends on what's missing. If what's missing is a side, we do trig. If what's missing is an angle, we do the inverse. So when we look at this one, we circle, here's an angle. Immediately I didn't circle an unknown, so I know I'm going to be using trig to find a missing side. I circle, I label, I pick a trig function, that's going to be tangent, and this is where I have to set it up to cross multiply because I'm missing a side length, not an angle. So I put this over 1 and cross multiply. Tangent of 39. It's not by itself, so I'm going to divide. And when I say it, I mean x is not by itself. And now I can go to my calculator once x gets by itself. So now I will take 11 divided by tangent of 39. Let's see, tangent of 39. And we're back to what we've done the previous days. And we get 13.6 for our missing side length. On number 2, I circle, and again, now immediately I see I'm missing an angle. So I go straight to x equals. Now I have to pick the inverse that's appropriate. Here's opposite, here's adjacent. And so just like I picked opposite and adjacent for tangent, now I'm going to pick the tangent inverse to find the angle. I know this side and this side, but I don't know the angle. So to my calculator for angle, I'm going to use second inverse tangent, 25 over 78. And so that angle is small. It's about 17.8 degrees. On number 3, circle and label. Circled an angle, so I know I'm going x equals. And I have opposite and hypotenuse across from 90. SOHCAHTOA tells me this should be sine inverse because that's what relates my opposite to my hypotenuse and then to my calculator. So I'll do second sine 10 over 19 to find my measurement here. So that angle is going to measure 31.8 degrees. When I find my inverse appropriately. On number 4, I circle and label. I have my adjacent side and my hypotenuse. Okay, notice I circled an angle I know, so I'm going to use our regular trig, cross multiply. So adjacent and hypotenuse, that will be the cosine of that known angle, is x over 28. So now I'm looking for this side. Over 1, I can cross multiply. 28 cosine of 46, and it's by itself, so I can go to my calculator. And so now I would type in 28 times cosine of 46. And now that side length I was missing is 19.5 when I round to the nearest tenth. And I don't know the units. Maybe it's miles, maybe it's inches. But on side lengths, I don't know. On angles, I know it's a degree. And on our last 2, again, we circle and label the sides. So that's always what we'll do. When we pick our trig, we know the angle. So this is where we're going to have to set up to cross multiply. Picking opposite hypotenuse is sine. So I would take the sine of that known angle is x over 31, opposite over hypotenuse. Put over 1 to cross multiply. And since x is by itself, go to your calculator. So now we would have sine of 31, times the sine of 24. And I get 12.6 rounded to the nearest tenth. Last one, I circle and label. I almost said opposite there, that's adjacent, close to it, and hypotenuse. So circled an angle, so I know I use an inverse trig, adjacent and hypotenuse. I'll pick inverse cosine, 31 out of 36, and go to my calculator to find this last missing angle. So cosine inverse based on the adjacent and hypotenuse. And 31 out of 36. That missing angle is 30.6. Do agrees. So today we practiced and reviewed finding the side, but introduced that idea of using inverse trig to find an angle. Let me know if you're having trouble finding that or following along, and I can help you out through that. Otherwise, have a great day.